Hi everyone, my name is Tika. Today, Peter and I, we're going to be talking about the migrations from open source Druid to Imply. And on the next slide, you'll be able to see our faces. So this is me, Tika, currently a sales engineer at Imply. I live in Dallas, Texas, and in my past life, my past career, I was a data engineer for the past 5 years. To you, Peter.
Thanks, Tika. My name is Peter Soderberg. I'm a senior solution architect with Imply. I live in Seattle. I've spent about a decade in analytics, getting insights out of fast data using Hadoop, Elastic, and now Imply. And we're excited to bring some of that experience to bear and talk about some things we've learned in the field going through some migrations.
Awesome. So we're going to be talking about a quick story. So the next slide is going to go into a quick the next slide is going to go over what it is. So let me paint you a picture, right? Once upon a time, there was company A, and they were currently on open source Druid, and they migrated to Imply Cloud. So being on open source Druid, yes, there were many positives out there. The first one is they're able to ingest streams. The second one being they're able to serve real-time queries. The third one being they're able to build data-driven apps on top. And the last one being faster time to data insights. Though there are multiple positivities, there were some problems that started to appear being on the open source part of it. The first one being it was hard to operate large Druid clusters and finding the people to operate them. So suppose if you wanted to apply config changes, you would have to SSH into them and apply those changes. And each change would have to be applied on each node. Upgrading was a challenge, right? Upgrading from maybe one area to the next area was a little bit of a challenge. The third one is they needed support for optimizing, and the support, suppose there is a ticket that opens up, right? An issue arises where it's like queries are dropping, or maybe you want to open up a ticket to get on possible optimization support. With that, you have to wait for the ticket to be going through and to be solved and someone to be assigned to you to help you out. But since they were able to go through Imply Cloud, they got the support they needed quicker and faster. And the last one is they started to notice some performance bottlenecks that began to happen. And because of that, they got less insight into cluster health. And so on the next slide, I'm going to be talking about why they migrated, like why this company A migrated. So if we go to the next slide, why company A migrated, we kind of chose, let's say, 5 main topic points that we think that was very beneficial for them. The first one being centralized configs through Imply Manager. I'm going to go a little bit about Imply Manager. So Imply Manager, if you guys aren't aware, it's this one centralized area where you can manage and create all your clusters. The second one being easy upgrades to newer versions of Druid, and a few features that, since they were able to do the upgrades and go through this, they were able to access new features like vectorizations and joins. So it was very beneficial for them to do those easy upgrades. The third one being break fix and proactive support. They got all the support they needed and a good SLA around it. The next one being insights into cluster performance through Imply Clarity. So Clarity, imagine it like a time travel tool, where you can go back in time to check maybe what an individual user was doing, or even check how a query performed and not having to go through all the logs. You pretty much you're also able to check like a cluster-wide view to see what else is going on at what time, and maybe if you wanted to even check at the same time or a specific time. And this one is ease of migrating and through query workloads. So that is why, because they went with Imply and they were able to migrate to Imply Cloud, they were able to leverage our experiences to do these migrations and have a little bit of less, ease of less. Those were the few things that that's why company A migrated. Going through why company A migrated, you might be thinking, yeah, this might be a situation for company A. And maybe there's other situations or other companies or organizations and say, hey, why should we migrate? So the next slide I'm going to go into is why we should migrate generally. And so out of this, there are three main, let's say like topics, right? Topics or subjects on why companies or people would want to migrate. The first one being new infrastructure. And having new infrastructure, suppose you want to move to a newer, faster server or even a new environment, right? It can be newer, it can be faster, it can be cheaper. That's why you want to upgrade your servers. The second thing is maybe you want to move from your on-prem to cloud. So everything can be stored there. The third one could be cloud to cloud. Let's suppose you are on a private cloud and you want to move to a public cloud. Or let's say you want to stick to one specific cloud or stay within that one cloud provider. So that's kind of with the new infrastructure. With the next one, it says migrating between old version of Druid to Imply. I know that's why company A migrated, but I'm going to go a little bit into it. Company A migrated because they wanted manager clarity and pivot. So I'm going to go into a little bit more detail into this. So the first one is manager, and I was mentioning how they wanted to have a centralized config or area where they can manage all that. Right? With manager, as I mentioned, it's that one place where you can manage and create all your clusters. So let me give you. Suppose you want to increase your, let's say JVM heap, right, for your historical nodes. You'll be able to do all of that there. And clarity, which is kind of like their observability. Sorry, I couldn't say that word. It's kind of just where you monitor and you can improve on your cluster performance. Area where you can just be like, hey, I want this to be optimized, or I want this to be, give it more power, X, Y, and Z, right? The next one is pivot. So imagine pivot being your visualization for your data. So it's kind of like all the analytics that are present about data, and you can present that there, or you can visualize that there. And the good thing is you can have historical data, you can have live data, you can have any type of data and be able to visualize that as it goes on. Suppose you are, working with Kafka. You use Kafka as your source and you use that live data and visualize all that data live as it moves. You can set it up to however long you want, maybe a month, weekly, even secondly, however you want, you'll be able to view that live data. And the best thing is, since it is very tightly coupled with Druid, it works together with Druid rather than the other visualization tools out there. And I know there are plenty with Druid, and that's like a plus point. And the next one I have on there is like support SLA, right? We want to get the support we need. Something breaks down, we need help with something, maybe we need advice with something. All of that, we want to have that right SLA. So since these applications have gained popularity and they were able to support the production workloads, and we were even able to get like SLA around that support, like to help company A out. The last point I have on here is migrating to Imply Cloud. So I have 2 points on here. The first one is migrating to Imply Cloud. We are experts on hosting Druid workloads. Imply automates managing that specific infrastructure in your VPCs. So it helps the ease of customers. And since Imply will be able to manage the infrastructure, you'll be able to work with it, easier. And let's suppose you have a cloud team, right? And you don't want to move to Imply Cloud. You have your own. If you're not doing that, you have to work with multiple teams, right? You can have your cloud infrastructure team, you can have your DevOps team, you can have multiple teams that you would have to work with and then put your stuff together. But with Imply Cloud, you have all of that in kind of like one centralized area, and it'll be, easy for the customers to go through. And so that's kind of just why we migrate generally. And these are just 3 main points that, that Peter and I thought about that, oh yeah, this is what we needed. And so next we're going to kind of go into, things to consider, right? When you are doing the migrations, what are the things to consider? Maybe the environment you have, right? What are the things to consider? So I'm actually going to pass it on to Peter to go over all the different things to consider. Take it away, Peter.
Great. Yeah, thanks a lot, Tika. So diving in here, it's important to know that Druid or Imply isn't just fast queries. I mean, yes, that is, but it's also a running system, almost a living, breathing system where we're constantly ingesting data and serving those queries to users or other systems. And when we prepare for a migration, we need to make sure that all of these things come across smoothly. And the easiest way to think about that is breaking these into the different 3 groups of assets, where we have some things to think about on the data side, some things to think about on the config side, and then how we're going to migrate the queries from the old cluster to the new cluster. So based on our desired new cluster and current cluster settings, we'll have some choices to make. And finally, one thing to note is, while migrating across versions is definitely possible, it's important to compare release notes and compatibility and deprecation to make sure that the future system that we're landing on will be exactly what we want. So first I'll dive in and let's start talking about the data, because that is obviously a good first step. And I'll take a step back, and when we're starting to plan out a migration, it makes sense to ask a few of these questions, and these questions can determine what sort of choices we make and how successful this will be. Remember, we're building a new plane while we're in flight, so as we're upgrading, changing these sort of living systems, we need to make sure that we come up with the right approach, often a phased approach, to ensure that there's no downtime or manageable downtime. Essentially, keeping an eye on everything that we do that would have an impact on the business, because there's a reason somebody's relying on Druid to serve these queries, and we want to make sure that it keeps providing that value while we're going through upgrades and migrations. So, first question is, will we want both the old and new running? I think definitely yes, in most cases, where we want to have, at some point, we want to have both systems ingesting continuously so that we can make that comparison, make sure that the new cluster we've built is doing everything that the old cluster did. So I think, especially for Company A here, we liked having a point where both old and new were running, and then we could make that decision to decommission the old cluster after some testing. Is the new cluster empty? It's often easiest to start with an empty new cluster, but that's certainly not the only way to do it. There's some caveats around data source name collisions, but otherwise, we can migrate to a new cluster that's already serving some different workloads, as long as there's some capacity. We can make some decisions based on what the data sources are, how they come into Druid. So whether it's, there's some considerations for batch files and a different set of considerations when we're going after streaming data. On the streaming side, it's great to take advantage of the retention in the topic and the way that Druid knows Kafka or Kinesis offsets to be able to make sure that when we migrate a workload, we can take advantage of, we can get only the data that we need, and often that's tied to an offset. Finally, one key point here is the streaming topic retention. Often, a Kafka topic might have 7 days of data in it. And if the Druid data retention requirement is 7 days, boom, we can just ingest from the beginning of the stream, and we'll have enough data to start serving our real-time workloads. So let's dive into migrating ingestion. So one key consideration here is keeping an eye on how ingest is currently managed. And one of the goals of generally, planning out this migration is taking advantage. We don't want to waste work that has been done previously. So often there's some system for managing ingest, depending on when the cluster was created. Sometimes it's in the data loader UI. I know that released in Druid 15, or I think, anyway. So it's great to have the Druid UI as one sort of central management place for your ingestion, but often other systems are involved. So maybe it's Postman or some other way of submitting these ingest jobs. And if we want to leverage some of that existing infrastructure, great. Now, bear in mind that when we submit an ingestion spec, that will create a new data source in the new cluster if that doesn't already exist. And that's a key consideration depending on whether we're migrating, whether we have to backfill segments or we just want to start an ingestion job to create the data source, and that will ultimately be what's being served from the new cluster. So I know I talked a little bit on the differences to consider for batch versus streaming. So one key consideration on the batch files is that are the files still there? One recommendation we have is to always have the source files around available in case we need to re-ingest. This is one example of how we would need to do that. Now, that's not always the case. Sometimes the daily batches only live around for long enough to be ingested. So based on the determinations for the source data, we can choose whether we can just resubmit batch ingest jobs in the new cluster, or we have to do something slightly harder to get that data in there. And we'll go into that later. Finally, in the streaming, on the streaming side, it's great to talk about. It's great to take advantage of any topic retention we might have. So being able to, if you're currently ingesting from the latest offset, you could just submit an ingest job and start from the earliest offset and grab all of the data available in that Kafka topic. Then based on, we can wait and fill into the desired data retention in the new cluster, and that would potentially save us some work and some risk in terms of migrating segment files themselves. One consideration is, will the jobs have enough resources to run? Often some of the care and feeding that goes into Druid is tuning these ingestion specs to make sure that the memory settings are exactly where we want them to be. So if we, obviously, if we have some tuning in ingestion spec and we submit that into a new cluster that's wildly different from the old cluster, we might have a bad time. So just, being careful that we should know the resource requirements for these jobs and make sure that there's probably enough resources for them to run. And my final point on ingestion spec is backwards compatibility. It's great to be able to have, to take advantage of submitting any version of ingestion spec into a new version of Imply. That said, when you rely on backwards compatibility, you might not be able to take advantage of some new features. So one example that we saw is as we're bringing Kafka ingestion over, there's a newer feature that lets us log the parse exceptions. One common area of ingest glitches is figuring out why a message was unparsable. So being able to take advantage of a Druid feature to have that unparsable message logged right in the log files can make this development easier. That's something we weren't able to do in some of the earlier versions of Druid, but now we can take advantage of that. So as we're submitting older versions of ingestion spec, we might want to refactor some of those to take advantage of that. Similarly, we have deprecated the parse spec in favor of input format. This makes our Kafka ingest a whole lot more robust and easy to use. That said, we can continue to submit ingest spec with using the parser, but the data loader UI will throw an error. So you can, it's simply copying and pasting some of the fields in the ingest spec to different places. So pretty quick, but the question is whether that effort's worth it. So, I think you're going to hear me say this a few times, but we're sort of making data source by data source decisions here, and with the end goal of minimizing business impact, but also, not throwing away old work. Okay, so, we've ingested as much, we've copied as much ingest spec as possible, but unfortunately this won't cover all of our use cases. So finally, migrating segments if we have to or want to. So we would do this if we can't re-ingest from source or we don't want to. Either the Kafka topics or streaming topics don't have the retention that we need, or perhaps the source files for batch ingest aren't still around or available. So then we do need to go ahead and migrate segments that were ingested from one Druid cluster and migrate them over to the other. Now, bear in mind, this is a two-step process. We need to copy both the segment data and the segment metadata. So the segment data are what live in deep storage. And as a refresher, those are pulled onto the historicals into their segment cache, and those are what the queries are served from. But we need to have the original source of that segment in deep storage. So we're able to copy directly, often from one S3 bucket to another, or whatever your deep storage location is, maybe one HDFS location to another. But either way, move just the segments that we care about into the new location in deep storage. Next, we'll pull in some rows from the Druid segments table. And you can see I have a snippet of a Druid segments table down at the bottom. And just it has the segment metadata, what data source name it is, the intervals it covers, and then but somewhere in there is the payload column, and this contains a deep storage path. So if we change the deep storage location, we need to tell the segment metadata to look for the segment data in a new location. If we want one more wrinkle, we can take a look and see that this is where you don't want to go, where we've told the segment data, we've put the segment metadata in, so we know there should be segments there, but for some reason Druid isn't finding them. Either we didn't copy them correctly, or we didn't upload the payload, didn't change the payload column, so it's looking at the old path. Anyway, we want to make sure that that we load all the segments that we want. And then, as I was talking about updating that payload column, there's one more thing to remember. And if you're using Postgres to store this, not only is it stored in the payload column, but the payload column is stored as a byte array. So it's in binary. And if we want to change, let's say we're going from Druid Warehouse to imply Druid Warehouse as our deep storage, we can, while we're updating the segment metadata, we can replace, go from binary out to text, do our replacement, and then convert it back to binary and insert that into the Druid segments table. One final point here is that Druid data source table does store the latest commit. So we have the option available if we want to copy in all of these, migrate some old historical segments using this method, then update Druid data source with the latest commit. And finally, if we kick off the same ingest spec for this data source, it would go to the Druid data source table, find out where the commit is, and start ingesting after that offset. So I think the takeaway here is that it's certainly possible, but it's a little complicated and a little risky. So we need to be very careful and sure that we want to do it. So the next talks about migrating data. So that's the bulk of it, but we also want to bring across some configs. The major question to ask here is, how tuned was the old cluster? As I said before, there's a lot of effort that's always going on to keep memory tunings and other optimizations. So one of the easiest ways to make sure that some of those configs still apply is to create a new cluster with similar infrastructure shapes. This will make the ingestion tuning applicable to the new cluster. And bear in mind, it's both easier to optimize in later versions, and it's easier, and we can take advantage of some other tools. So One key thing that we determined is that we only want to bring across the configs that we know we need. It's often easier to, as Tika was saying, once we have clarity so that we can see how the cluster is performing, and so that we can, when we have imply manager, configuration changes become a whole lot easier. So the recommendation is that we bring across the configs that we know we need, and then wait till we can rely on manager clarity and do the tuning later when in the newer cluster that might be taking advantage of some other features. Finally, how do we move our queries across? It's we're not just moving a system. It's very important to know what your downstream users are doing. So the users in a dashboard, the query performance it's a different query experience from a system serving backend API calls to another system. We want to keep in mind what the requirements of Druid are from the users, and make sure that we can meet those or be clear about when we won't meet those for brief downtimes. So often in a data application, there might be some application code that's generating these queries. So this is why we were talking about being careful about comparing the versions in the release notes. So the major change in queries is deprecating select in favor of scan. So if there's a lot of application code firing off select queries, there might be some updating. That said, lots of queries will perform the same way in Druid 12 versus 22 and what have you. So ideally, we could change the load balancer to point to the new router, and the users would get queries and would get their queries returned and wouldn't know that it's coming from a new system. So as I said, on the comparing versions and release notes, so Company A, they migrated from Druid to Imply Cloud. And the two big advantages here that I'm going to call out are the simple management of these Druid clusters, and also simple future upgrades. So how does that work in practice? We can see that the Druid 12 was released in 2018, and that's when it was installed, and immediately began serving real-time and historical queries to data-driven applications. Over the next couple of years, Druid continued to improve, evolve. I'll call out just a couple of features that were important to this company to be able to, that were worth some effort to upgrade. So we saw that Druid 15 included general GA SQL, as well as the data loader UI. Later that year, query vectorization it debuted. On the flip side, in 2020, we deprecated select in favor of scan. So yes, we're adding some features, but that's one deprecation to be aware of. And then finally, another huge feature was including joins. But over these intervening couple of years, it hadn't been possible for this company to do an upgrade. Either it was too difficult, or there were other pressing business concerns that meant that it wasn't worth finding the time to upgrade. Then we were able to perform this migration into Imply Cloud. So finally, they're on the latest version of Druid and are also able to lock in future upgrades pretty easily, where it's easy enough to either spin up a new cluster, test a new version, spin that down, or just do a couple of clicks and we can upgrade to a newer version of that same cluster in Imply Cloud. Great, so let's jump into some of the steps that we followed, and what we're trying to do and how we go about doing that. So In our current architecture, and this will be broadly familiar to a lot of Druid installations, where we have source data coming from somewhere, whether it's IoT devices, click streams, logs, and events, lots of sources of raw data. And two main places they land, either a data lake or a stream. So far, so good. Then we take these from either in a batch ingest or a stream ingest and send them into the Druid analytics engine. And finally, on the right-hand side, this application is and submitting queries to the analytics engine, Druid, and getting results out. Now, as we go through our migration, we've basically installed a new imply cluster and migrated the ingest tasks so that at this point we have the old version of Druid and the new version of imply running and doing the same, making sure the data are being ingested, and we can make sure that the application can query the new cluster the same way it could query the old cluster. So this is right now we're on a happy path. We have if something isn't going right in the new version, we have the old version still running and can fall back to that. But if we've proved it out that, hey, the application's behaving better, or at least at the SLA, then we can go ahead and decommission the old cluster. And now everyone's happier running this, managing and configuring this analytics engine, and the application is still able to get the same fast queries it could before. So what were these individual steps that went into that? So we followed that. We knew we wanted to create a new cluster, and we wanted to create an imply cloud so that we could take advantage of our expertise in hosting Druid workloads and automating as much of this as possible. We made sure that the new cluster could access the deep storage and metastore of the old cluster, and included some configurations, but not all. And so some of the configurations we added are we wanted to keep some of the job tuning the same so that the broadly similar hardware shapes meant that the jobs would generally run. In terms of migrating data and ingestion, it really was a data source by data source decision. And for the majority of the streaming jobs, we could just copy over the ingestion spec and take as much data was in the stream and then let it fill going forward. There were some batch files that could simply copy that ingestion spec around, and as long as we could get to where the source files are stored, so far so good. And then finally, there was one topic that needed to have the segments ingested by the old cluster migrated to the new cluster, and then ingest continued from where the migrated data stopped. So it really is worth it to sit down and figure out, what each data source requires and how that can power queries to our users. Started out with some simple testing, just hey, how many rows are there for each hour for each data source? And that can prove that that we're ingesting the same data into both the old and the new cluster. Then finally, we can migrate some queries. Start by taking some of the more complex queries from the old cluster, see if they run in the new cluster. So far, so good. And then it is the happy moment of pointing the load balancer to the new router, and things just work. Finally, we get to decommission the old cluster, free up those resources to power some new projects. So these are the steps we followed, and you might think about how these steps might apply in your potential migration, where we want to create a new cluster, and there's some options about where that is, but Imply Cloud is a great way to do it and to test the functionality of new versions. As long as we can have a way to get either to get the source data over into there, we're great, and we get to pick what configurations we need to bring across. Finally, or in the middle, go data source by data source generally, and figure out what it'll take to bring it across. And the planning up front can cause, mitigate some headaches down the line. And then finally, migrate the queries, either pointing the load balancer to the new cluster, or installing a new or sending users to a pivot dashboard. Other ways, any way that we need to get these insights out of the new cluster, we can do that. Great. So I hope I've shown how one company made some decisions around migration and got them into a happier place, and hope that's food for thought for potential future migrations.
So now we're just going to go into some questions. If you guys have any questions, like, feel free to type it in the answer them. Thanks, Victoria. Cool. No questions. So I think everyone understood what we said, right, Peter? I guess we gave a pretty clear presentation.
Or they're busy migrating some of their own data.
Migrating their own stuff. Awesome. But yeah, if you guys do have any questions, you can definitely reach out to Peter and I. We'll definitely be able to answer those questions. Oh, there's a question. So the first one says, are the versions of Druid use the same format of metadata and deep storage?
That's a great question. So going from 12 onwards, yes. And I don't have it right in front of me, but there was a point in time when you can't copy you can't migrate you can't backfill the data the way I described. So if you're going from, we did this fine going from 12 onwards, but if it's much older than the point remains the same. Check some release notes, comparing your individual versions.
Yep, hope that answers your question. Cool. I think there's some in the Q&A. Okay, there's another one that says new feature rollouts of OSS and Imply.
Yeah, so good question. Did it just go away? Anyway, the Imply version tends to be a couple months ahead of the open source version. So you will get access to the features in Druid. It just takes a little bit longer to get integrated.
Awesome. Excuse me. Cool. No other questions coming in yet. Okay, awesome. Yep, there's no other questions. So thank you everyone for coming to the session.